Alright, so I'm Kayla Ruffner and I'm going to be presenting today on the spectroscopy of methanol and other simple molecules. In this lab, the purpose was to identify compounds using infrared spectroscopy and nuclear magnetic resonance spectroscopy. Infrared is based on, they both measure the electromagnetic radiation in molecules. Infrared is basically to find the functional groups in molecules based on their Lewis structures, when nuclear magnetic resonance is finding the number of peaks and the ratio of areas to identify those molecules using range of absorptions. We identified 15 compounds in this experiment, like methanol to butanol to propanol, etc. And functional groups were determined based on the IR spectra, like I just said, and we also used NMR using graphs to identify all of our compounds, especially unknowns. So example, like an IR spectra, you could have a 3500 and 3100, and that would be an H singly bonded to a oxygen atom. And then the NMR, which is used to find the number of integrations, is you can have a ratio with a 6 to 1 to 1. These are some of the compounds that we decided to do research on. These are all their Lewis structures, so this is what you would use to find the IR spectra for each compound based on functional groups. And there's the rest of them, some of them. And this is the table used for NMR. So like your O to H is a 3500, 3100 range of absorption. So you would use the graph and you base on their peaks, and then you pretty much just base it on the ratio of areas, and then you would determine your unknowns that way. So I decided to look into methanol. I found out it's a colorless flammable liquid, and it's also used as it's organically synthesized in an antifreeze, and it's used for fuel. It's polar at room temperature, and it's also a denatured additive for ethanol, and is manufactured for industrial uses. Not really much to do with humans. It's basically just for industrial, so like anything to do with cars or automotive. And that was based on the references down there from Science and Technology, and that's its Lewis structure. This is the NMR for methanol, so like these are the peaks you use to determine the ratio of areas, so you're able to determine that it's methanol for sure. And its functional groups, it has an O to H and also a C to H singly bonded, and then these were the rest of the functional groups that were found in all the rest of the compounds. And methanol has 2 peaks, so its ratio is 3 to 1. So that was helped to determine to make sure you had the right compound, and as well as the rest of the compounds. My 3 unknowns were mesotylene, 2-butanol, and 1,2-dibromomethylpropane. And these were kind of difficult to determine due to the way their graphs were, because some peaks, they weren't long enough to determine as peaks. But as I got down to it, they ended up being C to H benzene ring. There really wasn't no C double O bond, and their peaks were based on the graphs. So it was easier to determine the NMR based the IR, because you're able to see something visual instead of going off of a Lewis structure. So that was my presentation, and those were my unknowns, and here are my references.